just hold it in my hand?
No, you can keep it down there.
Oh.
I was just keeping it on there.
Oh, you can just keep it there.
But you,
No clip.
You can just hold it or you can.
Oh, here. Yeah. Put it there. Just here? Yeah. That worked for me? Okay. So this is joint work with colleagues from the business school and students at ISI. Most of this work actually was done by the students, Eric and Balak and Gorangi. So what are we trying to do? So the problem is really, very simple to state. Suppose that I had two companies. Wouldn't it be cool if I had a similarity function which gave a high value when these companies are competitors of each other, which means that they provide similar products and services. So the idea is basically to build this graph where you have links between companies and the strength of the link represents how much they compete. And so that's pretty much it. So we want to do that for every company, not just publicly traded companies. We want to base it on publicly available information so that it can be maintained and it's free. And we want to do this over time. So we want to understand how this similarity function changes over time. So this work was really inspired by our colleagues from the business school, Gary Holberg and Gerard Phillips. And you can go to that webpage to see what they did before. And the data that they have is available. And it's available for basically the publicly traded companies. And the goal of the project that we are engaged in right now is to grow this to every company. And I put in large font something that is in this tiny font on the left. Competitors are firms residing in those in close proximity in product space to each firm based on a continuous thing that got cut up by the slides after they got moved to this laptop. And they published a paper that you can download to sort of get more details on what they did before. And it's sort of well respected, cited, the data has been used a lot, is publicly available. And so what they did is they constructed this similarity function based on the 10K filings of the companies. And what they did is they extracted 600 words from the description, so they parsed the 10K, they extract the part of the description that comes at the beginning in the expectation that the beginning is where companies talk about what they do. Then they extract nouns with a fairly simple technique. They just look them up in WordNet to see if they are possibly nouns. They don't actually run a post-tag parser, and then they remove very frequent and very infrequent words, and then they compute Jacquard similarity. And they tuned this and they created their data, and it works really well. And they have some sort of business metrics to actually evaluate that the similarities make sense, which I don't fully understand, but they are in the paper. And so what we're trying to do in this work, where we now have a bunch of computer scientists in the team, is to grow from the 5,000 publicly traded companies, or at least the ones for which they have data, to basically more than 300,000 companies. And instead of using 10K filings, the idea is to use the company website, which may contain thousands of documents. If you think of Amazon, if you try to crawl Amazon, you get in trouble quickly. So there's a challenge there. in TNIC, the relevant text was pretty obvious. The description is relevant. The 600 words from the beginning of the description are very relevant. When you crawl a company's website, you get all kinds of irrelevant text. And then, of course, there's a scale issue. We're going to have more than 100 million documents, so this can get expensive and difficult to compute with. So those are, the red are really the challenges of this new work, and I'll be presenting some preliminary results. So the approach is simple. Crawl the website, extract useful words, build some kind of feature vector based on this these words, and then compute similarity between these vectors. And you can use any metric to compute the similarity. That's really not where the challenge is. So we're using the Wayback Machine so that we can get historical data. And if you multiply out those numbers, you see this is a lot of pages. So that's one of the big challenges. And what we're doing is really just limiting to a breadth-first, two-level crawl so that we don't go deep inside our website. And we're limiting to 500 pages because we believe if we don't get the relevant pages in the two-level crawl, we're not going to get them. Or we'll get so many pages, it'll be very difficult to figure out which ones are relevant. So we decided to start small, and we basically are looking at just these companies in this preliminary study. And we computed ground truth for this company. So we basically say, we know which ones are competitors. They are, each color is a segment, and all those firms are actually competitors. And the task that we engaged in is, if we throw in all the pages for these companies, can we actually segregate them into these colors? And so what we started with is, for extracting useful words, let's just use all the words except stop words. And then we try to grow the baseline into, can we do better by identifying which pages are useful, or can we do better by identifying what words are useful? And so when we run the baseline and we evaluated against this, it looked like we had scrambled the companies randomly. I mean, in one of the meetings, I actually asked one of the students, are you sure that our NDCG scores are sorted, descending, not ascending? Because some of the, correct results were at the bottom. So using all the words is not a good idea. And this clued us in that this problem was actually going to be very, very difficult. So the problem is, so we said, okay, let's try to classify the useful pages. And so we did a sort of small analysis, and then we couldn't agree among ourselves which pages are useful. So we thought, an annotation task is not going to work because we're not going to get any sort of agreement between annotators about which pages are really useful. We also try to identify useful pages through URL patterns, like a company has an about page and so on. And those are high precision but very low recall. So we abandoned the idea of trying to identify useful pages and went back to the idea, can we identify useful words? And so what we did is we went back to the original idea that your colleagues had used with the 10K filings. And what we did is we basically used the words that they extracted from the 10K filings as seed words and build a glossary with that. Applying more fancy NLP techniques, we now extract adjectives and proper nouns because we believe those are probably also descriptive of the products and services. And then we do the same thing. We remove frequent and infrequent words, and with this we build glossaries. And these glossaries then are supposed to just contain nouns and adjectives that are relevant for products and services. And then the approach becomes very simple. Crawl the website, extracts words using these glossaries, build a feature vector, compute similarity. Here's an example. So if you look at these words that are basically the words of a company filtered by the glossary, what sector do you think this company is in?
Travel.
Travel. Yes, close. It's excellent. AlaskaAir.com. But I mean, I guess for most of you, you're looking at this and it's like, I have no idea. It's not so easy. So how about this one?
Why are they into eggs? Both of these had eggs.
They serve eggs on flights, or So this gives you an idea that this is not. We haven't solved this problem yet. We're doing much better, but if for a human it's so hard to see these words and actually classify these industries, you can see that this is going to still get us in trouble. But we actually evaluated this with our small data set, and this is the results that it produced. So the construction companies are hard. So one of the construction companies ended up in communications, and a creative company ended up in a construction company, actually, very high at the top. But at least we're not getting random results now. We are getting results that sort of resemble the ground truth, and so we're really working now and sort of tuning the way that we process the words. And we have tried various good ideas that turn out to be bad ideas. They added jargon words. And we thought, okay, the jargon words for products are going to help. Ran the evaluations. They actually made the things worse. So we're still struggling with that part of the problem, but we're making progress. So we decided to grow a bit and to actually use the web pages of the publicly traded companies to try to recreate the same network similarities that were created from the 10Ks. So we extracted the glossaries from the 10Ks, but now the input to do the classification is not the 10Ks, is the pages that we crawled for those companies from the web. And so, I mean, this is basically the approach. We use the glossaries from TNIC, the old project, but we use it on web pages. And we don't, this is current work, we don't get as good results as they get before, but we are now within a few percentage of the results that they were able to produce for 4,000 companies, for 100 companies. When we grow it to 4,000, then it goes a little bit worse. So I think we know we are on the right track, but we haven't actually solved it yet. And then, of course, the eventual goal is to go big and do this for every company. So one of the good things is we're getting a crawl from the Wayback Machine for all these companies. So we're getting the 19 years of data for these 300,000 companies from the Wayback Machine on a hard disk. And so I don't know what the licensing restrictions are, but you know, if they allow us, then we will share this data. That's it. Thank you.
How do you deal with companies that change over time?
So, yeah, that's a good question. Dealing with companies that change over time. So the idea is to measure this similarity year by year, and then use of techniques in networks that can sort of analyze how networks change over time. This is one of the most interesting aspects of doing this work, at least for the business school people. Yeah.
In terms of the industries that you're going after, right, you showed how you have 5 categories. There's a loose parallel between some of the standard industry codes and what you're doing here. Is an expected output of this effort also some additional terminology in terms of here is a industry classification and here are companies and how they fit in those classifications?
Yeah, that's a good question that I can't not answer from the business point of view. So, I mean, as computer scientists, we want to cluster the companies once we build a network, we'll do clustering, and then it'll be interesting to see how these clusters line up with the standard industry classifications. We expect the clusters to be more fine-grained, but it'll be very interesting to find if there's clusters that actually span multiple classifications, because maybe those classifications were old and companies now don't fit nicely into them. I don't know that.
You had Google in there, and you're going to have companies not necessarily with they change over time, but they do multiple things.
Amazon is a classical example, right? Several years ago, most of us would have put Amazon in one place. Now they are in multiple categories.
Yeah.
So in your example, you don't have Amazon, you have Amazon Web Services and the Google Cloud Platform. So
Yes.
are you doing any sort of sub-clustering within companies to find divisions or subgroups or?
No, we're starting from the root URLs, and so for Amazon, this is the root URL that comes from, I don't know, there's some kind of standard set of URLs that you can download for this, and then Amazon is actually already segregated like that.
Thanks, Pedro. If people have more questions, let's take it during lunch. Okay. Thank you.
Yeah, sorry, okay.
Next talk will be by Jay. He's going to be talking about building knowledge graphs by analyzing textual documents.
Just So I'm going to talk about extracting knowledge graphs from financial filings. And so my goals when I started out, I was using the FEII data, and it had triples, and triples are often the basis of a knowledge graph. So my question was, can you build a useful knowledge graph from the unstructured text that you might be given in a filing? And I've mainly used a different set of techniques, but in this case I wanted to do something fully unsupervised using a class of techniques called OpenIE, which I'll discuss a little bit later. And I wanted to sort of add on to these techniques many different signals that you can get from the text, and then somehow use some collective structure between all of the knowledge that's in the text to decide what's relevant and irrelevant. And as you probably got from Luika's little introduction, there were a lot of confounding factors which made it very difficult to do this task. But I sort of have the basis of what I think will be a promising direction going forward, and I kind of want to discuss what I did along the way. So sort of the first element here is structured knowledge, and I don't know exactly what communities everyone comes from, so I'm going to give you a little brief idea of what a knowledge graph looks like. So basically you have text, it can be multimodal, so you can have YouTube videos, you can have news articles, you can have Wikipedia pages, and you want to, from that text, get and video and audio, get a structured representation of the entities and the relationships between them. And this is sort of a theme we've seen in many of the discussions today. So from this sort of collection of documents about Barack Obama's historic visit to Cuba, you might get some relationships about Barack Obama and his spouse, his actual employment, his nationality, and the same for Raul and Fidel Castro. So this is sort of the high-level problem, and so it boils down to three basic tasks. One is figuring out who are the entities that are important in the knowledge graph. So who are the nodes in this graph? Next is figuring out what sort of types or labels they have. So in economic data, you might have different types of roles, such as the actual companies, but as well as the financing that might be given to the company, or sort of the products those companies make. So these are sorts of examples of types and attributes we might annotate each entity with. And lastly, we want to look at how these entities are related. And so we had competitors in Pedro's talk, and in the FEII data, we saw there was a list of about 10 major types, such as affiliates or guarantors or counterparties. So these are the sorts of outputs I was hoping to sort of integrate into this knowledge graph. And so, in case you're unaware, knowledge graphs are everywhere. Every major informational firm has some version of a knowledge graph that's in use today, and there are many, many startups that are now popping up and trying to use these knowledge graphs to answer questions and provide decision support, have intelligent agents that integrate with our everyday life. So this is sort of becoming an important problem. And so for this problem, I wanted to try something new. I wanted to try open information extraction. And so when I say open information extraction, people who have been doing information extraction generally fall into two camps. There's the ontology-based camp and the open camp. And in the ontology-based camp, you start with a predefined set of relations. You have a schema of what the entities are and their types. And then for each of those elements of the schema, you can learn a set of patterns using some manually annotated data. And the nice thing about this is that the extractors are often fairly high precision. The main issue is that the recall is constrained by what you tell your system to extract. So in contrast, open information extraction, everything comes from the text. So everything comes from natural language processing on the text. And once you parse that text, you do a task called semantic role labeling. You actually get the relationships which are important in the knowledge graph. And this is very, very noisy. And so this was the technique I wanted to see if there was a way to make it useful for these filings. And so the simplest sort of example is if you have text like this, for example, because Ally controls Ally Bank, Ally is an affiliate of Ally Bank for the purposes of affiliate transaction restrictions, OpenIE does incredibly well. You get Ally controls Ally Bank, and Ally is an affiliate of Ally Bank. This Ally affiliate Ally Bank is one of the triples in the task, and so this was the first example I saw, and I was really excited. I was like, okay, this is I'm done. This is what all of the text is going to be like, and I'm going to be able to regenerate all of the triples in the challenge, and I'll be able to decide which ones are relevant. Then I looked at sort of some more complicated text. So, Bank of America entered into definitive agreements with two different counterparties on some day with an additional counterparty to sell servicing rights on certain residential mortgage loan serviced for Freddie Mac, Fannie Mae, the Government National Mortgage Association, etc. And really what you get from this is not very clear. Bank of America has agreements with two different counterparties, but it doesn't actually get the relationship between those counterparties. And then there are a bunch of relationships that we should be able to pull out from this, but we're not really getting. And so one of the questions I had was, how can we make this more useful? How can we get the sorts of triples that look like this in our knowledge graph and avoid sort of these meandering and imprecise triples? And so the next thing I turned to was using some level of topic modeling, which is another unsupervised technique to summarize data. And so basically, we want to use this unsupervised summarization approach to be able to pull out something interesting or some sort of cohesive set of categories or topics from our data. And so if we can capture at a course level the co-occurrences, the patterns, we can use that distributional information to guide what is relevant and irrelevant, what should be salient in the corpus versus what is something that's either too specific or too general to be useful. And so here are some topics that I learned from the full set of 10K filings, which the DSMM organizers were nice enough to supply me with. So looking at this, I was again a little more hopeful because you actually get some nice clusters of text and clusters of ideas. So here you can see sort of energy. You can see in blue right there's a nice mortgage set of terms. On the top right in green, you can see credit cards, and then you can see in some cases very clear brokerage firms and brokerage companies. So I think this again was useful, and one of the ideas I had was, okay, let's try and use these topics to guide how to build this knowledge graph.
This was with all the text in the 10.
Yes.
Okay.
So I think it was roughly 600 10K filings. Yeah, and so I think there's probably more to be done here in terms of pulling out the real set of terms and the real entities. And one of the ideas that I've been using actually is using this as a first level filter to figure out what a useful entity is, as well as a useful relationship. And so these are all the building blocks of what I hope is a knowledge fusion technique that's going to pull in a lot of different ideas and a lot of different signals. And so a lot of my research has been using probabilistic models that combine and fuse information. And this, I think, is sort of the real novelty of what I'm hoping to do. So we have a system we developed at the University of Maryland, at the University of California, Santa Cruz, called probabilistic soft logic. And it's a probabilistic model that uses as its input declarative rules. But each of these rules is the basis for a probabilistic graphical model. So it's generating relationships between evidence and outputs, as well as forming a collective structure across the different predictions. So in this case, what we want to predict is whether a triple is relevant for a knowledge graph. And so the sorts of rules that you can specify will encode these intuitions that we have about what makes a good OpenIE relationship. So one might be that if the relational phrase that's extracted is short, like controls or is an affiliate of, that's going to become the basis of a relevant triple. So if we can use the length of the phrase and its saliency, the salience of the verb in the phrase, that might be the basis for finding relevant triples. And that sort of is that first set of extractions that I presented, controls is an affiliate of. In the second set, we saw topics. And one idea that you might have is that if the entities that participate in a triple belong to the same topic, then they're going to be relevant. And so, here's another signal that we can incorporate. And we could also do something that finds, for a set of relationships, the type, the domain or selectional preference that that relation is associated with, and see if there's a coherence between that inferred domain and the type from a type predictor that we get from the text. And again, that might allow us to determine when a triple is relevant. And then something that I think Liga mentioned earlier today is that what the real opportunity is that once you find some relevant things, you can use them as the basis or core to expand out and find other relevant things and create a structured set of relevant triples, not just triples in isolation. So I think this is one of the really interesting questions is how can we find structure such that an overlap between, for example, entity 1 in a relevant triple with some relationship with entity 2 allows us then to determine that other relationships with other entities are ones we want to include and need to find in the text. And so this, I think, is sort of the vision for this work. And just to give you a little bit more background on how this is going to happen is that I talked about probabilistic soft logic. So we're going to have these rules. Each of the predictions is going to take a value in the continuous space between 0 and 1, which allows us to provide a confidence for each of the relevancies. So how relevant a triple is might depend on all of these rules, but what's ultimately going to come out is something that you can interpret as a probability of relevance. And then the optimization regime is actually is going to formulate each of those rules as a hinge law. So basically a rule when you have a cohesive set of inferences is going to have no penalty, and then as you have sort of an incohesive set of inputs such as a low relevancy for something with a short relational phrase and a salient verb, then you're going to have higher penalties. So this is sort of the underlying framework, which then we're going to translate into an optimization objective, which is convex. And we're going to be able to solve this relatively fast and get fairly bounded results at a 3/4 optimality. So as I said, this is very preliminary work, and I would like to use the full set of 10K filings to generate a knowledge graph, and then run this PSL model that I've shown you on that large set of data and generating a more cohesive set of outputs. And then finally, once there's some sort of initial system, it'd be nice to have an operational toolkit that does all of this in the unsupervised setting on whatever data you throw at it, whether it's the web pages that are getting crawled from this WTNIC or other types of financial filings beyond just the 10Ks. And so have this end-to-end system that does something a little more intelligent with this unstructured text. So I'm looking forward to what's coming next year and seeing if there's some way to have this be a component of what either the task is or what the evaluation looks like. And so just to summarize again, we saw three things. This knowledge graph, which came from OpenIE, signals like topic models, and a collective structure that we put together with the probabilistic model.
Any quick questions for Jay?
So I would add that you could also have, like if one triple is true, it negates another triple.
Yeah, I like that example.
Right.
So I think if you had like some
Right,
set
so
of...
maybe these guys are going to talk a little bit about that, maybe.
Correct. So a lot of what you said, Jay, I'm hoping will be revisited when we discuss about the planning for the next year of the challenge in terms of various dimensions. What is the task? What is the data? How do we formulate the task so that we get subject matter expertise, and what kind of models we want to build?
Mhm.
So some of that will come later in the afternoon.
Okay.
Thanks again. Yes, Ben.
Oh.
Do you have a sense whether you have come up with sort of a complete or enough, big enough set of rules?
No, those are just, for the purpose of presentation, those are sort of the different flavors, but I think there's a lot of space there to come up with different ways of combining these signals. So I would not call that complete, just an illustration of the different things that we can do.
Thank you. So the next two talks will be presentations from two of the teams that participated in the challenge. First would be Elizabeth from the Thomson Reuters team.
Hello, everyone. So yeah, I'm Liz from Thomson Reuters Labs, Boston, and I'll just be talking about our solution for the FEIII challenge. I'd like to mention that most of the story is actually undertaken by 3 of our undergraduate interns that were with us for a month in January. So this all took place over the course of a month, and I think that it was exciting that we could get so far in 1 month. So I'll just get into it. So yeah, so the FEIII challenge, I'll just summarize it again. We had a corpus of triples that had been extracted from these SEC filings, and I think a total of 25 different filer and companies. And we had 10 roles that describe the relationship between the filer company and a mentioned company in that triple. About 1,000 triples have been annotated for our training set, and we had like maybe another larger unlabeled set of triples. And this is just an example of what we saw in the training set. Including, and some of this initial labeling was a little bit confusing to us because we had some kind of rating from the annotator about relevancy, and then in some comments they would say the role is not correct or something. So we did have questions about that, and I think like in the end the evaluations that it was handled a little bit differently. So this was one of the challenges that we had, was how do we try to rank these triples that are highly relevant and also validating role. And if I'm not sure if this was covered already, but the discounted cumulative gain was how we were internally evaluating ourselves, as well as accuracy, which was just a fraction of correct like labels per label divided by the total number of triples. And then for the unscored task, we did get a little bit into trying to predict the role, using machine learning to predict the role, because we really felt that one of the things that we wish we had was better features for being able to detect whether the actual role was correct or not in the triple. So our approach was really just use supervised machine learning to learn the labels. And what we thought we could do, in addition to just analyzing the text, was to really bring in the external knowledge about these companies that we have in Thomson Reuters' own knowledge bases, to try to see if that could help us understand whether this role is correct or whether it's likely that there's any kind of relationship between these companies. And we also did look at information extraction from the sentences with using NLP tools like our own Calais, which is kind of tailored to looking to help people who are working in quantitative finance in those areas to analyze the news and other unstructured information. So, and also using word embeddings, which probably was one of the most key parts of the solution. So most of the work here was really just feature engineering, and we used just off-the-shelf machine learning classifiers. So before I get into talking about the features that we extracted, the data prep, we were given this set of labeled data, and we just divided it into a 20% test, 80% training, and this was selected at random. So we just randomly took 20% of the data set and used it as our testing set, and we just converted annotations, the different annotations, into numerical scores, and we also, and if there was a disagreement with the annotators, we think we just averaged their ratings. And we had initially we did do some basic extraction from the text of looking at numbers and dates and things, but ultimately I think we ended up realizing that most of the word embeddings were like a lot more powerful than these. Another thing I should talk about before I get into the actual knowledge sources is permanent identifier. So all of these knowledge sources that we have are kind of keyed by this permanent identifier, which is sort of like a RIC, if you're familiar, or a CIK. So it's just another identifier, but it's something that we try to maintain over time, and it's also unique for every company over time. Like sometimes the RICs or something get reused. So this helps us enormously in the task of extracting the different information sources, because we only had to look up one identifier and then go in with all these data sources and using that one identifier, and that made it a lot easier. And PermID our PermID solution also comes with a matcher, so you can bring in a list of company names, and you can output or try to match using string matching and other techniques to the permanent identifier. And so using this technique, I mean, all of the file entities are taken care of, because CIK, there's a easy conversion from that to PermID, but for mentioned entities, we are able to match those to the PermID 72% of the time. So for 30% of the time, we won't have any data. We won't have like features for 30%. And so, in terms of the quality of the matching, we had a good amount that were like 70% that were excellent or good, and 26% possible. So that could introduce some errors into our technique. If we could get that matching quality up a little higher, it would make things better. So then I'll go into talking about how we analyze the text with Calais, which is one of our, or Thomson Reuters Intelligent Tagging, which is one of our tools that it's actually all, I should also mention, all of these knowledge sources are actually available open source, so they're available for free for people to use. So Calais, really what this is showing is kind of a screenshot of the tool we have online. I've just uploaded one of the snippets of text from the 10K filings, and Calais is able to identify companies, locations. It's able to identify certain types of relationships between the entities in the document, and it also provides different. It identifies industries as well that are mentioned in the document, and these things called social tags, which are kind of like topics. What they are trying to find the documents in the pages in Wikipedia that are most similar to the query document, and then they extract out the Wikipedia folksonomy tags that correspond to those wiki pages that were found to be most similar. So they're kind of like a topic in a way. And then it also extracts mentions of currencies, which I thought was kind of important because some of the techniques, like word embeddings, they'll try to, or when you're working with text, a lot of people throw out numbers and things, and maybe like actually looking at the numbers was really important. So I thought, currencies was another good one. Although in this open text, this open version, I don't think that the currency is available, but internally we had that available. Another source, so as Jay was talking about, like all these companies having knowledge graphs, Thomson Reuters also has its own knowledge graph that it's created from its own data sources. It's called Data Fusion, and there's hundreds of millions of connections in this graph. It's pulled from things like our Reuters news. We have supply chain data. We also have like legal documents and various other types of things like director and officer information has all been pulled together, and is all linked through Perm ID also. So you can do things like ask for like the paths between two Perm IDs, and it'll return to you a list of a visual. We have a visualization of the graph, which is kind of messy. It needs to be weeded, filtered down a little bit more with the types of relationships. So here, for example, we have is supplier relationship between RPT, Dell, and VMware. I guess Dell and VMware. So what we did for this was some of the features we used from this were just to look at the path between filer company and mention company that had a person in that path, and those in different length paths. So this would hopefully capture things like maybe affiliate relationship, where we want to have a lot of common ownership and leadership of companies. We also thought it was important to kind of look at the actual industries of the companies. So, is this company in banking or is this company in insurance? Perhaps that will help to figure out whether that relationship is correct or not. So we used our Thomson Reuters business classification. That's also easily available in our organization authority database. And the TRBC code, we just use the prime. So there can be multiple industries for a company, and we just use the primary one that as in the database. And the TRBC, if you don't know, it's our own industry classification that is sort of a hierarchical one, and it's up to 5 levels. here I'm just showing an example of part of that tree. And then finally, we also used word embeddings, which are kind of a standard now in NLP. And this actually ended up being like one of the things that quickly got us a higher accuracy and NDCG score internally when we were testing it. But initially, we thought we could pre-train on the 10K filing text, but it turned out it turned out the Google pre-trained word vectors that were trained on the Google News were better probably because there's only 30,000 words in the text, so we had to move on. And then we also did try experimenting a little bit with some other libraries like fast text, and we also tried support vector machine with term frequency, inverse document frequency features. Both of these proved to be not as working as well as the word embeddings plus all the other tons of external knowledge features. So yeah, so here's this was an internal evaluation that we did between different methods, and our final one was actually an ensemble of 3 classifiers using the various features that I described earlier. And I should also mention, so for the external evaluation, we did seem to perform pretty well on the single ranking metrics. We definitely suffered where there was an emphasis on trying to rank those triples that had validated role higher, probably because our training data didn't have that information, so we didn't know whether when our machine learning classifier was trying to discern the difference between highly relevant ones or trying to even find highly relevant ones, it didn't have the information about whether it was validating the role or not, so it didn't make any distinction between that. So that's not very surprising. We also use the same exact features for role, except for the actual role. We did have a feature, and I don't think I mentioned this before, but we did treat the role as a categorical feature for our relevance prediction, but for our role prediction, we left that out. And so the idea is that maybe it could be possible to use machine learning classifier for the role prediction as well, and have the machine learning classifier try to figure out what the erroneous roles are. So that's something that we kind of started on, but we haven't. We did a preliminary result using the roles and started annotating some role correctness triples. So that could be something that in the future, if we try to continue work on that, would be another feature for the relevance prediction. And with this, we were also able to construct, with the triple data set, we did construct a graph and kind of look at the most central companies using various metrics. And one thing that was very interesting about this is that we found that the graph was connected across all the input data, which we thought that was pretty interesting. Okay, and these are just some of the most central companies that were found. It seems like across the different metrics, federal home loan mortgage came up. I do think that betweenness centrality was not very helpful in this case. I think what it was really finding was mostly the filer companies. Right. So that's it. Summary of our submission to the FEIII challenge. Thank you.
Any questions for Elizabeth?
I think the idea of role prediction for a pair of companies is kind of interesting. So that might be something that we want to think of for next year.
One other question is, you did multiple other subtasks along the way to bring the different resources together. Do you have any measurement of how accurate they were in accumulation. So in other words, you mentioned about how only 72% of the actual entities you were able to link, and even those only to a certain degree, right? Now, it'll be interesting to see whether it can be augmented by improving the data in the first place that was provided with the challenge, right? Or is it more an algorithmic challenge, like a combination of the last year's task and this year's task, to resolve entities mentioned as accurately as possible and then bring in augmented data?
Yeah, it's hard to say which one would be more of a booster, but yeah, I think that there are many things that we could try to do to improve the matching, and it's hard to say though which. I don't have an intuition for which would work.
So, in which way did you use the word embeddings? As you said, you used the pre-trained ones, but of course you have an entire sentence. Do you just average them?
Yeah, we basically take a TF-IDF weighted average of the word embeddings.
Thank you. Okay, so the next speaker will be Ray Wang from IBM Research.
Is lunch being provided?
I believe so.
Okay. So we may be about 5 minutes late, or,
Maybe 10 minutes late.
okay. I'll try to keep mine short.
So, given how the coffee break for your own food.
I know.
Hello everyone, thanks for coming to the talk. I'm Ray. I'm going to present our approach to this year's SCORED task. This is a joint work with Doug, Laura, Sika, Linyao, and Huayu in IBM Research Hamilton. So we will basically go over, briefly describe what is this year's SCORED challenge task, and then we will come to our approach. And besides of this, we will talk about something interesting we found in this task in the talk also. Okay, sorry. So basically in the task, the tuple is defined as a context, consisting context, file entity, mentioned entity, and role. For example, this one. And the relation triplets besides the context, the remaining parts forms as a relation triple. Okay, the task is going to doing the following thing. So going to do the relation triple ranking to rank the relation triplets such that the triplets that best the context that best supports role assignment, or the context contains the relevant knowledge or interesting knowledge about the entities will be ranked at the top of the ranking. Okay, so the challenge also provides us 4 labels to label each triplet to say how the context supports the role assignment or represents the knowledge about entities. For example, this one, the label is relevant. It represents the context is relevant to the 2 entities. Okay, I think before we're trying to derive any solution into any problem, we need to know what is a key challenge in this task. So we actually found conclude two main challenge in this task. The first is about the financial domain. Okay, we observe many evidence that shows high expertise or difficulties in financial domain. The first is we found that in many triplets, actually there's lots of complex financial relationships, which means a single context can contains many multiple relationships. For example, this one, it contains 5 entities and there are 2 roles in the same context, which is, I think, even hard for human machine will be this will be also a difficult task for the machine to handle this kind of cases. The second thing is about the labeling guideline. Okay, so I think in the triplets, in the data, we find lots of entities actually. For example, the final entity, we found the USA. Actually, USA is, I think it's not a financial entity. So a clear definition about what is the entity is useful in the labeling guideline. Another thing is the ambiguous entity mentions. So we found PNC is actually appears in many relation triplets in the data, but the PNC can refer to PNC financial services or refers to PNC bank. This kind of stuff will also influence the labeling, right? So this will be very different. The last thing we observe in the data is ambiguities in the label data. So for the expertise, even 15% of the cases, they actually disagree on their label. Okay, so this is really hard to label if the financial domain there's unclear guidelines in the financial domain. Okay, we think domain features will be needed to try to address these kind of challenges in financial domain. Okay, we will talk about this later. Another challenge is about the learning method. So I think the problem itself is designed as a ranking task. So as we know, ranking task is always trained on millions of training samples. For example, search engine requires millions of training samples to train a good ranking model. But what we have is 900 samples. This is a real example. So we are thinking probably there should be an alternative to way to train a ranking model or other things we need to study. And another thing is labeling schema provides us category information, right? So we are thinking about whether we can use classification rather than ranking to tackle this task. Okay, if we are agree to use the classification model, there are lots of models can be selected to perform this task. So which one is the best one? Absolutely, there's no model actually is perfect among all the tasks. So we are thinking about an ensemble classification model could be useful in this case. It will try to leverage the advantages and the properties of different classification models. So our approach is simple. Okay, so we want to leverage the domain features that is useful to relieve the challenges in financial domain, right? And then we have the features. We want to make use of the features in the ensemble classification model. Okay, so domain features and plus ensemble classification model is our approach towards this score task. Let's first talk about the domain features. So we basically define two types of features. One is the generic features, basically it's just unigram diagram. Another one is the domain features. So let's focus on these domain features. So for domain features, we have two different types of features. The first feature is type of features, a vocabulary feature. It aims to identify the candidate entity and the roles appears in the context. Okay, and the second is the relation pattern features. What it do is try to leverage the gap or the relationship between the mentioned of the matched entities and roles, or roles and the roles, to try to identify the similarities between this kind of entity and roles. Okay, I will give an example. Given this context, the candidate entities is we actually build a financial entity dictionary and then just to match it out, right? So in this context, we can find the PNC Market Street of funding as entities. And we can also, similarly, we can also find the roles as a seller. For the relation pattern, I give you an example. So we have this market, this entity matched, and we have the seller matched. Then we will generate the post tags in the gap of each token in the gap between this entity and the role, right? So this kind of feature give us like provides us the opportunity to capture the syntactic and the semantic relationship in the context regarding to the entities and roles. So this gives us more opportunity to explore how the model will make use of, model will decide about this. Okay, so all the features we actually extracted using IBM Research System T. It's easy to use. If you are interested, you can use this. Okay, for the ensemble model, we are actually using AdaBoost. Okay, so the ensemble model, the input will contains classifiers. So we provide 3 base classifiers to the ensemble model. One is a linear classifier, logistic regression. Another is nonlinear kernel-based classifier, SVM. And we also use a pairwise learning to rank in the base classifiers. So the AdaBoost pipeline will be like the following. So first, it will initialize the weights of each sample in the training data. Then the sample will be used to compute the arrow of the classifier because you know the ground truth of some labels. And then the arrow will be used to update the sample weights. And then this process will be iteratively to update the weights. And finally, we are using the weights together to produce the probability. Okay, so we are using the probability of the classifier make prediction on each instance as a final output. And then because it's a probability, so we basically can provide a ranking list on the test data. So let's talk about the evaluation. So the task actually using NDCG as a standard ranking metric. So we provide a rank list. If the rank list is similar to the ground truth rank list, the score should be 1. So the higher should be better regarding to NDCG score. And the competition also provides different weighting method to the NDCG, so we can look at different perspective of NDCG results. So our approach actually achieves the highest score in 4 out of 6 evaluation metrics, which again shows effectiveness of our approach. Okay, and we actually take a close look into the model. Here, I basically show the top important features in the ensemble model. Okay, we can see that the percentage of the dominant features is larger than the generic features. Okay, among the most important ones. So this again shows that the dominant features are effective to handle the financial domain or the difficulties in financial domain. Another things that we also look into the ensemble model. Okay, so we compare ensemble model to the 3 base classifiers. We found that the base classifier even they perform very well in the training data, but it will overfitting to the training data. It will perform not that good on the test data. Okay, so we actually can show that AdaBoost ensemble model is robust in this case. Okay, we finally use ensemble model outputs in our submission. Okay. So besides of the approach, our approach, and we actually look back towards this problem from the definition, labeling, and our approach, and towards evaluation. We actually have some interesting findings I want to share to you. Okay, the first thing we found is the most important thing is that we found that there are a very important challenge, which is semantic complexity in the original challenge task definition. Okay, so given the original task is given a tuple, and these 3 are forms as a relation triple, and the original definition, challenge definition, want to validate 2 things. One thing is that it wants to validate the financial relationship in the triple is validated in the context. Another dimension is that there are interesting and relevant knowledges in the context that are relevant to the financial entities in the triplets. Okay, these two are the two dimensions in the challenge definition. So I think this will be very challenging because these are two dimensions. I will show an example to tell you why I think this is challenging. So here are two examples. This is a context. This is a one tuple, and the challenge in the training data that gives this sample a highly relevant label. Okay, but actually this triple or this tuple actually only satisfy the dimension 2. Okay, there contains some relevant knowledge about the file entity and the dimension entity, but this row is not validated between these two entities. Okay, so it does not satisfy the dimension 1. This one is similar. So the label according to this tuple is neutral. But what we found is actually this tuple actually satisfy the first dimension, which is validated financial entity relationships, but it does not validate the second one. So you can see there's a clear inconsistency in the labeling, right? Some of the label is relevant to dimension 1, and some of the label is relevant to dimension 2. So if the experts feel that its label is going to fall into each dimension, it will give a different label, right? Even the label is same, but the meaning of the label will be different. So this causes a major inconsistency in the labeling data. So what will be our solution is that we are actually deriving a new definition, which we call it as relation validation definition. So in this definition, we focus on the dimension 1, regarding of the dimension 2. Okay, we only concentrate on whether the tuplets is actually invalidated in the context. If the relationship of the financial triplets is validated. I will give you an example. So basically, if we have a different, if the relation, we also define a labeling schema, different labeling schema towards a labeling relation validation definition. So compared to the computation definition, highly relevant, neutral, irrelevant, what the relation validation definition concludes is validated if the context validates the relationship. Okay, partial relevant if one of the entities is confirmed not to be in the relationship. Okay, another one is invalid if a context invalidates the relationship. And irrelevant means that one of the entities, not a financial entity, or no entities actually, neither of them confirms the role. I will give you an example. Okay, this is a same example. So the original definition will label these triplets as highly relevant. And this one is neutral. So according to the relation validation definition, it will change this to invalidate. So because the role is not validated in the context. And this one will be labeled as validated because the role is validated in the context between these two entities. So we can say there is a big difference between if you just regardless of another dimension and only focus on one dimension. Okay. And what is effective? What will be this relation schema, validation schema impact the result of our approach? So we also do the experiments. So we relabel partial of the test data set and relabel partial of the training data set. And we train our model using the same approach, and we test on the relabeled test data set. We actually find a similar trend of the results. Actually, scores are very similar to our submission. And this shows that our approach consisting domain features and in some model are actually robust. Okay. And we also look into the model and to evaluate the effectiveness of feature and also how the inside model works. So we draw the same conclusion that domain features are effective, and also the adaptive model is robust, can be a solution to deal with the overfitting problem. Okay, finally, let's conclude this talk. First, we actually found some very interesting future explorations I think might be interesting to talk in this afternoon for the challenge. So I will basically briefly talk about this. So first, I think we think a process labeling schema will be very useful. So because the label of the original task definition is actually across multi dimensions, you can define labels based on different dimensions. So if we can provide a simplified definition or give a more qualified criteria to label the data, it will be better. The second one is now we actually are only given a tuple, right? So the context is after pre-processing. So we have a little knowledge about where the context is from. So I think it will be interesting to know that actually this context is from a list, this context is from section, so you have extra knowledge about how the context come from, so you will get more knowledge of the context. It will be helpful to provide a better score. The second one is we are similar, so we are only looking at the context. We do not know the global view of the context. It will be interesting to see where the context come from, and this kind of information can be very useful to make the prediction. The last one is a kind of for the challenge. So we think a unified framework for the financial domain relation understanding will be very useful. If the framework contains from the labeling a more precise labeling schema and providing a pool concluding lots of useful predefined domain features and ranking models, classification models to be choose from. And the evaluation matrix, I do not have time to look into to explain this section, but there could be different evaluation matrix to evaluate the different aspect of the problem. Okay, if this kind of thing can be unified in a framework, this will be very useful. If the other people, researchers might be interested in this area, they can directly work based on this kind of unified framework. And finally, we want to show three. I think there are three takeaways from this talk. First, I think it's important to know before you dive into the real task, you need to know what is the challenge. Okay, so our approach is towards using domain features towards the challenge of the task and make use of the features you find towards the challenge task. So domain features plus in some model is a way to address this kind of task. And we show the effectiveness of our approach in the result. And another thing is our exploration. So if we find the definition of the task is hard, so it might be interesting to think about it in a different way, try to simplify this or try to make it more precise. Okay, that's for today's talk. Thank you.
Thank you, Ray. So,
Thank you.
Any questions for Ray? Jim?
I noticed that actually the AWS did not really improve the F1 overall, so relative to SVM. So you were saying ensemble improved robustness, but it wasn't ultimately clear that was.
Yeah. You're right. So we showed actually two tables, right? One is on the challenge task, another is on the relation validation task. We are not saying in some model is always the best, but actually we at least observe one of them in some model kind of dealing with this overfitting problem. So we finally choose the in some model. So it actually works in at least one of the scenario. Yeah.
But is it also fair to say, Ray, that in the relationship validation definition, on the evaluation data set, both SVM and the ensemble model did equally well?
Yeah.
So there's something else different in the task definition across the two that needs further explanation.
Yes. Correct.
Yeah, so I'm new to the challenge, so I don't understand the actual nuances, but so how is this challenge different from just validating whether if those extractions are correct or incorrect? So you have some text, and you say, is this a correct extraction from this text? Is this so far a valid way to think about it?
When do you go ahead and answer?
Yes, so I think the relation validation definition is more towards your thinking on validating whether the role assignment towards to the two entities are validated in the context.
But, I mean, so what does it have to do with finance? Why isn't it just a generic sort of information extraction metric? Is this triple extracted correctly from this text?
So hold off to talk, Pedro. That's a valid point. We want to discuss that in the afternoon.
Mm-hmm.
And there are some aspects here which may, and the next iteration of the challenge, we may want to use additional evaluation metrics.
Yes.
And also, in general, some of these tasks are going to have a more, a parallel general purpose NLP parallel. The finance angle here would be the complexities of the language and the domain terminology that come in. Not necessarily in the task definition or the evaluation metric definition per se.
One thing you said this morning, which I thought was really interesting, is that whether that is new information, if you have some base set of knowledge and this was an addition to it. So I think that might actually make it less, less vanilla to say, is this actually an extension or an overlap?
So
Yeah.
there's an element of link prediction or
Yeah,
something
a new prediction versus something that's new. I mean, I don't want to put words in your mouth, but that was something I heard.
No, that's again a valid point, but again, in the general purpose NLP, there is a NIST challenge that tries to address evolution of knowledge and what is new in a very broad context, where Wikipedia is viewed as the knowledge, but if you go to Wikipedia, the difference between Ali Bank and Ali Financial Institution is not something that they would fully recognize. That level of difference between companies and subsidiaries and so on.
Mm-hmm.
Anyway, that would be a parallel between domain-specific tasks and generic tasks, and we would want to discuss about how we want to organize ourselves moving forward. That's a valid point. Thanks again, Ray.
Thank you.
So we are the last presentation for this session. Luika will be talking about relationships and how probabilistic topic models help in understanding relationships.
So I'll try to keep it short because, as Joe pointed out, we may not have lunch if we don't go there. Actually, how do I get back to the drive? No, to get back to the Google Drive. I'll just,
to the Google Drive.
yeah.
Here,
Okay.
right?
Yeah.
This one, right?
Yeah.
Okay. Okay. Okay.
So I'm going to go through this pretty fast. I'm going to talk about actually if we could use information in the financial supply chain to say something about the financial performance of financial products. And so let me give you a little bit about the background and what the supply chain is, and then how we try to find a model for this supply chain, a probabilistic model, and how we use that to come up with the potential for toxic financial communities, and then see whether that has an impact on the performance of securities. So the motivation for this, for example, the financial crisis, a big problem in the financial crisis was that you had these mortgage-backed securities. In general, mortgage-backed securities are good financial products, But if these mortgages are subprime mortgages, then eventually people can't pay mortgages over time, and so this becomes a bad financial product, put very simply. The idea of why this is a good financial product is because you're taking large tens of thousands of mortgage pools and assembling them together, and then you're coming up with distribution of risk, and so you can start off at the bottom with very secured things to at the top unsecured things. So this is ideally how things should work, but whether things actually work this way or not, we know it didn't, and so what I'm trying to see is whether this financial supply chain actually had an impact. So how are we going to get this supply chain? And this is something 3 years ago I started working with IBM, and we're still trying to put this data set together. So what we're doing is we can take the prospectus that is filed with the SEC, and then we can find, for example, the role that a company has played in this financial contract. So for example, you can see here that the originators of all the mortgages in this particular security, Wachovia Mortgage Loan Trust 2007, were National City Mortgage, Fifth Third Company, SunTrust, Wells Fargo, and so on. So what we were trying to do, so this is very similar, this is part of how we actually came to the 2017 challenge, was when we were actually pulling these out from these documents. And so what we want to be able to pull out is that these, so in this case, for example, we've pulled out 3 of the originators, we've missed out on a couple of the originators here, so there are, we're not 100% accurate. So, what's the assumption here of how we're going to build these communities? So financial entities, we think, will interact and form communities, and let's call these communities as topics. And these topics will be persistent, and that means that they won't, a community that's formed won't be just in one financial contract, but you will find them across multiple financial contracts. And the idea is that once a financial entity collaborates with another financial entity and creates a community, then there is a higher probability that they will continue to collaborate with in another contract in that same topic. And we're also suggesting that the role that a financial entity plays in one contract or one community will persist as it goes into another topic or into another contract. Now, if this is true, then the idea is that these are persistent topics, and so that sort of undercuts this principle of independent communities creating these financial contracts, because these mortgage pools are based on this idea that these are independent IID type of distributions of risk and so on. So if there are actually topics that persist, and if these topics are toxic, then this is going to cause a problem in this independence assumption. So I'm actually, in the interest of time, going to skip the details of the model. So let me just tell you in words what the idea is. So the topic model applied to documents basically says that a document is a collection of words, but another way to think of it is that a document is a distribution over topics, and the topic is a distribution over words. And so you're getting 2 different distributions, and that's what this topic modeling based on Dirichlet priors and the per word distribution, topic distribution over documents, and then document distribution over topics, and then topic distribution over words turns out to be. So in our case, what we're going to say is that a document is a financial contract. The words are either the financial entities, so a community would be a combination of financial entities, or another community would be the role financial entity pair, that's going to form the communities. And so let me just show you the visualization of This is over about 6,000 private label mortgages. And let me just highlight some of these things so you can see. So what you're seeing is a topic on the left-hand side, and then on the right-hand side are the financial entities that played a role, and whether it's thick or thin means how probable it is that the topic model tells us that that financial entity is in that topic. And you can see, for example, Wells Fargo is in a lot of topics, and that makes sense because Wells Fargo was very big in this business. You can also see at the bottom here, for example, Citi Mortgage and Citigroup forming a community, Bear Stearns and EMC, Lehman and Aurora. All of this makes sense because these are actually, there are ownership or they are subsidiaries or in close relationships with each other. So all of these communities do make sense. The role and community, so here what I've done is we've used the role financial entity pair, and then in this visualization we're hiding the role itself. So we're just showing the financial entity. Now compared to this one, so this is for the same data set, you can see Wells Fargo is important, but now you can see actually Countrywide, which is another big player, which was very small here. You can see when the role is put back in, Countrywide becomes more important. And so this is something that we need to understand from the distributions why this happens. So you start seeing Countrywide in many more topics, and then here's where you see what I've circled, the pink and the red there, First Horizon and AmeriQuest. These happen to be companies that were very heavily interested in the subprime, originating subprime mortgages. So this is where you actually see a topic and I can say that is a toxic topic. And actually when you can go even further, where you actually start putting the role label inside there, what you see topic 7 and topic 10, you see that these two sort of bad companies are actually playing originator role, service role, trustee role, etc. This is really bad because they are playing multiple roles in this financial contract. And so this is against sort of all of these principles of independence and risk sharing and so on that was supposed to be there when you put together these contracts. So what do we want to do with this now? So what we did was we're pulling out, for example, so each of these contracts, this is from the Bloomberg terminal, you can pull out lots of information about these securities, and the particular things that we're looking for example, is you can see there's the Moody's original and current rating, and S&P original and current rating, and then the other thing you can look at is also, so from top to bottom, the top are the ones that are more secure, at the bottom are the ones that are least secure, because this is sort of this waterfall payment. As the money comes in, you get paid if you're at the top, and then any money that's left behind gets all the way down to the bottom. And the other thing that we're also looking at is, for example, these zeros. If there are zeros in there, it means that original and then current, if it goes from a number to 0, it means that that note no longer has any value to it. So these are examples of, say, good, where you can see it went from AAA to maybe AA minus, which isn't that bad. And so here this is still doing reasonably well, but for example, when I take from First Horizon, you can see that it's gone from AAA to no rating, which is really bad, and then you've gone from 12 million to 0, which means that you've suddenly lost $12 million. And similarly here, you can see, so you're seeing now these securities associated with this toxic community looks like its performance is really bad. And so the future work that we want to do actually is build, now we're putting together this data set, and the idea being, in general, the financial entity and the role that it plays should not play a role in performance of a security. And so if we are able to put those in as additional features, and if that is actually explaining or providing additional features to tell you, to classify the performance of a security, then that would tell you that there is something bad happening in this system where the supply chain is actually playing a role that it shouldn't play.
How much time is between the original and the current?
So this is from 2000, up to 2007. So this is 10 years later. So this is the data set was from 2004 to 2007, and so this is 10 years later. So these are most of them with 15 or 30-year mortgages, and so they should be currently paying out. Okay, I'm done.
Okay. Any other questions later?
Well, you said you can detect toxic topics in this sense, but in your case, the toxic topic was only one company, so, and you already knew that that company is kind of toxic.
Actually, I didn't know. So when
Do you have topics where you can see that you have, I don't know, 3 or 4 different companies in one topic and all of them are bad companies? Or?
So we need to actually now go topic by topic and start looking at if that is the case. Yeah. Mm-hmm.
I'm sorry. What is the definition of a topic? I'm not sure you're talking about.
Well, I thought we were talking about topic models, so that would be dependent on wording and
No, in this particular
which
case.
documents.
So the two models are, in one, it's a collection of financial companies, and in the second model, it's a role played by the financial company.
Okay, thank you, Leka. Okay, we're going to break for lunch now. Lunch is again downstairs. I believe it's in the same area, Continental.
Let's bring up the schedule. So we need these people to come back 5 minutes early. So, yeah, you've got that. Yeah.
So lunch is in International South. I believe that's the second floor. And
So
the
Maya,
5 speakers.
Dennis, Tim, Rohit, and Ray, come back like 5 minutes early so we can load up your...
Actually, even better if, have all of you loaded your presentations already?
Well,
Where it's not here. Yeah.
Yet, okay. So let's ignore mine. The others, the other 4,
and where is the lunch?
it says International